So thank you so much for coming to the inaugural Delivery Conf. It's really, really exciting. It's funny because I was talking with Sasha and a bunch of people recently, and we were talking about how have things changed in software development over the past 10 years? What's the most dramatic thing? And in my opinion, automation around continuous integration, continuous delivery is really that transformative thing. I don't know how many of you were doing software development 10 years ago, but the amount of manual labor involved in taking that thing that you had built, wherever it was, even if it was on servers or in production or in a staging and test environment, and moving it through to production was really dramatic. And it changed so much about the way you did software development because now you had this automation that you could use to enforce good practices and making sure that your applications were operating within bounds and so on and so forth. And so I think it's really been quite transformative. The question is, how do we adapt that core software engineering thing to new domains? And what I'm going to talk to you about today is how to adapt CI/CD to machine learning and really help bring that same discipline to a large group of people that unfortunately haven't been given a lot of tools and things. So I am David Aronchick. I lead open source machine learning at Azure, open source machine learning strategy at Azure. That obviously is at Microsoft. And Microsoft has been using machine learning for a long time. We're very proud of it. We believe strongly in helping you with your data and augmenting it with Microsoft data, adding in the power of Azure and all our incredible flexibility and custom chips and so on, and then also doing breakthrough advancements. And when I say breakthrough advancements, we are very serious about giving back at Microsoft. You can see here just a small subset of Microsoft research things that we have invested in. ResNet, 96%. That's an object recognition model that we've given back. In 2017, human speech parity. In 2018, machine translation. In 2019, reading comprehension. All best-in-class research projects that we've re-released to the open source community because that's where ML is happening. And ML happens, obviously we weren't doing this just for fun and to advance the state of the art. We were doing it because literally every product at Microsoft uses machine learning. You can see it here, Office 365 and Windows and Xbox, Skype, Bing, so on and so forth. Machine learning is integrated into every one of these projects. And the reality is the amount of data that we process is so large we couldn't do anything but use machine learning to accomplish it. 180 million active users every month through Office are using machine learning tools. 18 billion queries asked of Cortana. And every day, the Microsoft Security Toolkit that runs on Windows and on Windows Server and on Exchange and on and on and on evaluates 6.5 trillion security events every day. These are things that if we were to use standard programming and standard techniques, we simply could not process it. There's no amount of human intervention that could accomplish this. So, this is something that we do in the ML industry. It's really bad on us. We say all these big words and we talk about how it's changing our world and making everything better. But what we hand to a lot of data scientists and ML engineers is that ML is very hard. And the reason is because most of ML is thought of to be just building a model. You take your data, you apply some complicated model with convolution layers and sigmoid functions and so on and so forth, and you process it and you get some answers. But the reality is that's not ML. ML is this. It is every step of the overall process, starting from data and going all the way through to your production environment. And not just once, many times. And that's incredibly important to internalize because if you just focus on building a model, yeah, your laptop is actually going to be great for that. But if you really want to do production-ready ML, you have to build pipelines like this. So you're a data scientist, you don't care, right? Wrong. You do care. And the reason you care is because of tweets like this. So many times a data scientist will evaluate a best-of-breed model on their laptop, on their private cluster, on the massive machine space heater in their corner with 4 GPUs in it. They've got a best-of-breed model. But that's not enough. You've got to bring it to production. And you see things like this all the time. The model is there, the artifact is there, 11 months later it's not in production yet. And the reason is because of this dichotomy that you see here. on your left, you see the data scientist, and she cares about using the latest frameworks. She wants to iterate extremely quickly. She wants to make constant changes to improve things, download academic research, download open source projects, pull in these libraries, and do cool things with it. And she really wants unlimited scale, because the faster she's able to do that iterative loop, the better she's going to be. On the other side, you have the SRE and the ML engineer. And the ML engineer wants almost the exact opposite. She wants to reuse the tooling that has already been approved across her enterprise. She wants to be in compliance with the overall governance that the lawyers and executives have decided. She wants to have observability. She wants to understand exactly what's going on when this model gets out to production and is being attacked for security or overloaded because it's Black Friday or whatever it might be. And she really, really cares about uptime. She can't go over and kick the machine when it's time to restart a training run. Okay, but we can bring these two together. We have the technology. Haven't I heard this before? The answer is yes, right? You heard this around GitOps, where you brought together Git plus your development plus operations. I don't know why I'm running off the bottom there, but OK. And what you saw is this great iterative loop. The developer was on one side of that circle. They would do that iterative loop. They'd run. They'd try it out. They'd get it going. And then they would check in the code. And from that point that they checked in the code, the automation system would take over on the right-hand side. And you would execute a build pipeline. You'd make sure your dependencies worked. You made sure that it was within compliance and all the necessary unit tests passed and so on. And then you would roll it out to production. And you'd be sure you knew exactly what was rolling out to production because everything was driven by Git. And so what we need to do is do the same thing, but with ML. And what that looks like is very similar. We start over there, just like a data scientist does today. She starts on her laptop. She starts with Jupyter. She starts with any of the latest frameworks and things like that, just to understand what's going on. But then she interacts with Git, and she starts that that GitOps-based pipeline, where she checks it in. It now integrates with the application, and then it just becomes an artifact with a pipeline that people already understand how to execute. And when you do that, you get the same benefits that you see here. We don't need to go through all of them, but you get automation and observability. So you know exactly what's running in production. You get static validation. You know that you're not going to have waste 2 days on a training run only to realize that some variable has been initialized, excuse me. And then finally, you get reproducibility and auditability. You know exactly what's running in production, and that's incredibly important with things that are fairly opaque right now, like ML models. And so we'll get to that in just a second, but like I said there at the bottom, you get velocity plus security, but for ML. So you do see a lot of internal MLOps platforms today. At Google, you have something called MLX, or externally they call it TensorFlow Extended. Facebook has FB Learner Flow. Unfortunately, you can't see that, but it's in the lower right-hand or lower left-hand corner. You have Uber's Michelangelo. At Microsoft, we have a platform called Ether. These are used internally extremely well because those data scientists are now able to focus on those models and then just move forward very quickly. But you're a big company. You don't want to work at a big company with thousands of ML engineers. You can build your own. And the way you would do that is this. You could start with a portable platform like Kubeflow. You could also start with a hosted platform. I do work at Azure. I'm going to mention Azure a few times here. But anytime you see the word Azure, you can substitute out any other hosted platform. In this case, Azure Machine Learning offers an endpoint to do training and inference and things like that. You take that, you layer on your code, whatever it might be, GitHub, GitLab, Bitbucket, whatever it might be, that you're able to execute event-based pipelines based on code check-ins. And then you add in your CI/CD platforms. And there are many of them. If you have spare time and you want to work on a side project, please don't work on a CI/CD platform. There are so many. Go work on one of these because they're all really good. But regardless, you can wire all these together. And I'll talk about some of the benefits of doing that in just a second. I did mention the cloud provider platforms. I'm going to take off my open source hat right now and put on my Azure hat just for a moment. Please excuse this short commercial break. But what you see here is a standard ML pipeline, right? You start over at Git, where you've checked in your code. It could be a Jupyter notebook or something like that. It could be raw Python. Doesn't really matter what. And then you kick off a CI/CD pipeline. And the data scientist is often in that left-hand side, where she's going to do a bunch of data processing, and she's going to execute initial training, or potentially full-scale production training. She's going to do hyperparameter searches, and so on and so forth. And then when she's done with that, it's going to go back and it's going to store that artifact in your repo and kick off the next portion of your CI/CD pipeline, where you're going to roll out to a staging environment. You're going to roll out to make sure you're doing model profiling to make sure it matches your production environment and so on, and then finally roll out to production. So this is a very common pattern. And what you want is you want a CI/CD platform that is neutral, that can basically take any platform or any service that's out there and integrate it into this platform, because that's how quickly ML is happening today. And some of the things that we offer on Azure, but you can, again, use whatever you'd like, are things like this: model versioning and storage. You want to have a first-class way to store the artifacts that you're rolling out. And you can do this with a standard API endpoint that we have here in our SDK. You want to do model validation, for example, where you take that model and now you run through an entire set of smoke tests to make sure the thing actually works, and so on and so forth. Maybe you want a service that does model profiling. So you hand the model over, and it runs across an entire array, a matrix of memory and CPU, and sees what the most efficient way to run this model is. Or maybe you want to use it for model deployment, where you're doing A/B testing, multi-arm bandit, so on and so forth. These are all services that you can get. Okay? So all that pipeline, it seems like a lot of work. Why can't I just build it on my laptop, roll it out? Because of this, right? The reality is that as much as you want to skip this and skip those 11 steps, or those 11 months, you need a pre-built pipeline in order to do that quickly and do it repeatably. And like I said, it gets you that end-to-end ownership where you continuously are delivering value over and over and over again. But you're doing that with compliance. Okay, so I hope I've made a convincing case, but I can see in your faces you're questioning, why do I want to use a CI/CD pipeline? I could just do it myself, right? Okay, let me give you 3 examples why an automated, pre-built CI/CD pipeline is critical for your MLOps solution. First, does my model actually work? Let me paint you a play. Play in one act. You have on one side your data scientist. She's over there. She's testing out her model. On the right-hand side, you have your ML engineer with her production environment. She runs her model. She tests it out. All looks good. She's looking at TensorBoard, everything under the curve, converging quickly. This looks great. Let's move it out to production. She throws it onto GitHub. And presto, fire. SRE's not happy. Why? Why is SRE not happy? This is, I literally posted this to Twitter. I said, what experiences have you had with your ML models when you've rolled them out to production? I got this back within like minutes. People, there's so many things that can go wrong with your ML model. Just about anything that goes wrong with your standard SRE, or your standard applications, yet it's, for some reason we think, oh, models are immune to this. Or it just doesn't work at all, right? That happens too. It's crazy, but true. And the reason is because that data scientist who was sitting there building her model on that laptop didn't explore all of these things. She was very focused on what her key metrics were. Am I converging? What does my area under the curve look like? All these good things. But the reality is there's a lot of other concerns that really you only face when you bring things to production. So the solution is a pipeline. And the pipeline looks like this. She checks it into GitHub, or Git of your choice, trying very hard to be neutral here. And then you run through an automated set of tests. You clean the code, you do automated validation and profiling, you explain it for bias. Maybe you package it for rollout using standard dependencies, standard containers, things like that. And then you do sane deployments with canaries, and then 1%, 10% exponential rollout and things like that. And now the SRE is a lot happier because it's gone through the same pipeline that you would use for any other development environment. Incredibly important, and really a transformation for what happens today. So you say, well, I can do all these manually, right? I can run a model profiler on my laptop. I can, lint it. I can do syntax checking, and so on and so forth. The answer is no, you can't. Because even if you trained every data scientist and you had all the tools necessary and they all worked together and ML and SRE knew each other and on and on and on, you would still need a written record of what you had done. Because that's what auditability means. That's this artifact that you're rolling out to production that you're really going to need no matter when you have it out there. And the idea that you're going to do that through some manual instruction set on someone's laptop, obviously that just never happens. So you really do need a pipeline in order to make this work properly. OK, that's MLOps. So does my model actually work? I think I've shown that you really need a pipeline, an ML pipeline, in order to make sure it works properly. So second, what did my customers see? You're like, OK, well, what the hell does that mean? Let me paint you another play. So here we have, on the right-hand side, we have our customer, and she's interested in getting a loan. And on the left-hand side, you have your poor SRE who's just rolling out things to production because that's what she does. So the person comes by and says, I'd like a loan. The front end of the website says, no, you may not have a loan. And the customer says, well, I have great credit. Why aren't you giving me a loan? And now you have lawyers. So the answer is why? It's not just about explainability, right? Here I have a woman who's looking at it, but think about it from much more systemic bias, systemic racism. You need to understand what is going on with your system. And not just that model, but exactly what data you trained on, what the outliers you use to exclude, what the statistics for the model are, especially across protected classes. What you do, what's the skew between the code and data you trained on versus production, and on and on and on. So there are many, many things you want to detail here as you move forward to avoid that nightmare case. So what you would do is you go back and you use that pipeline. So now we have our pipeline there, and for each one of those, you create a SHA, or you create some sort of signature to understand exactly that this is the step we use to build it. Then you create a holistic look and say, these are all the sub-steps, and this is all the steps put together. And this is exactly what I use to train. So now you store that in an immutable data store, and when your customer comes along and says, why didn't I get a loan, you can say, well, here's the model that we used, and here was the pipeline, and now we understand. Now, this is only the starting point for it. You're still going to need the very rich tools and the research and things out there to do explainability. But without that, you can't even begin to use those tools because you won't even know what you used to build the model and give the person the answer. Make sense? OK, so that's what my customers see. And now the third thing is my model still good? You're like, well, what the hell does that mean? All right, a third play for you. See, look, you come for a CI/CD, you get theater for free. I would like to paint you. We have a barn. Inside the barn, you have a blue duck or a yellow duck. And my question to you is, what color is the duck? Well, we're going to use machine learning because machine learning is the best. And I'm going to build a model. I'm going to study the barn and say, well, I think that here's my model, and it's ready to detect what is in the model, what is in there. And I say it's a blue duck. OK, so is that correct? Well, let's see. The first thing that you need to do is really understand what the population looks like. Because I trained as though there were 50% blue ducks and 50% yellow ducks in the thing. But there aren't. There are 995 yellow ducks in the population. And there's 5 blue ducks in the population. OK? So the accuracy of my model, I'm telling you right now, is 99%. And the false positive rate is 1%. What do you think the likelihood that it is actually a blue duck? Anyone want to take a guess? This guy knows. This is, by the way, presentation 101. You want to have as much statistics and math in your presentation as you possibly can. This is what this guy came up with, Bayesian theorem. And what matters is the accuracy depends on the population distribution. Well, what the hell does that mean? That means that if your population is highly skewed, you need to train with that in mind. So your model understands the skew of the population. Otherwise, you're going to be wrong. And you want to know how wrong you are in this case? You're wrong 2/3 of the time. So literally, if I studied this and got my model response, it would be better for me to take the reverse answer than it would be to take the answer that I currently have. Again, assuming that I knew it was a blue duck. All right? So that's how bad it can get. And you're like, well, that doesn't happen in real life. Wrong. For example, facial recognition. The population is not full of criminals. It's very, very small percent of the population is actually criminals. Yet we're handing out facial recognition, and I'm sorry to report there are large cloud companies doing this, that said, oh, you know what, we're going to use facial recognition to detect criminals. You know what, you're wrong. You're going to be wrong 2/3 of the time. In this case, 28 members of Congress were identified as criminals. Sadly true, but there you go. And you're like, well, it doesn't affect me. Wrong, because you can't opt out. Because you're going and you're flying, and guess what? You're being facial recognized as we speak. All right? So it's not good. And this is why it's so critical that these things are transparent and understood. And you can address it, but you really need to address it with an automated pipeline and detection of bias and things like that. And so what you do is you retrain with the understanding that the system is, looking at data that is 995 yellow ducks, 5 blue ducks. We're going to retrain, and now we get a good answer. It is in fact a blue duck, except it's springtime and things migrated. And now instead of 995 blue ducks or yellow ducks, we have 500, and we have 500. It's now even Steven. And now I'm going to get bad results because I trained previously. And this is why you need an automated system, because models can go stale very, very quickly. And that as your data changes, you need to execute an automated pipeline that will be able to retrain on the new updated data and profile as fast as you possibly can. And it's not uncommon at all that you're going to want to roll back multiple versions. And so you're going to need to keep those old pipelines in place too with the old data and so on and so forth. And again, these are the kind of things that are simply not efficient for you to try and track manually. Having automated systems that understand all these is critical. Okay. So I hope I've convinced you. These are three core things that everyone will face as you roll machine learning out to production. You really need to have these automated systems in order to get things going properly. And we really are just at the beginning of machine learning MLOps. Today, most of these steps that you saw here are fairly manual. They are not first class. They aren't like built into libraries and so on. They really are things that you've had to write yourself, which is not ideal. But if you use even what we have today, you're able to get best practices for building machine learning operations or machine learning solutions. You can download many of these all over the web. You get a repeatable workflow that you're going to be able to track going forward and be able to audit and revise over time. You get an immutable record of what's actually running. And most importantly, you get that lineage that allows you to, at any point in the future, go back and say exactly what happened where. You can say this log happened here, and we're able to go forward. And with all of that, you get acceleration of that data scientist doing that work, moving through to production. And that 11 months quickly becomes as fast as rolling out any other code into production. What's next? So I think that this is something we are all as an industry pushing forward, and I'll go through a few of these just really quickly. One of the things that I think is really, really important right now is around that yellow duck, blue duck scenario, to simplify monitoring of what's going on out there, especially around statistics and studying things like data drift, and being able to pull that information back and using it as a trigger for when you need to re-execute your model pipeline. That said, when you do that retraining, it may not change, but you should do the retraining just so you have the updated model and know that the data drift did or did not affect the ultimate results. Second, MLOps. Most of the MLOps you saw that I talked about today was really focused on that training pipeline through from the export of the data all the way through to production. But I think you can really expand it in both directions. We need to do better around our data pipelines, tracking what's going on, what the sharding and split and so on were, but then also the rollout to production. And doing it in profiling, particularly in things like edge case scenarios where your devices are going to be very, very lightweight and not have the right and not have the same profile as a server. We want to get a lot more enterprisey around MLOps as well. The unit testing and overall testing is not great right now. We need to do a lot better around security and auditing and things of that sort. And then do a lot better around resource management right now. Models that roll out often are far, far too large for what they're doing. Their latency and so on profiles are not great, and we can do a lot better with that. And then finally, and this is a really big passion area of mine, what I want to do is develop a set of standards that works across the entire industry for all of those steps. And so what that means is we should, for every step, for data ingestion, data export, training, hyperparameter evaluation, model packaging, model serving, so on and so forth, we should have standards, not necessarily IETF standards, just standards that we all agree on that can be vetted and linted and presented as part of APIs that we use to drive our CI/CD pipelines. And this is something we're underway getting going right now. But if you're interested in that, please find me afterward because there's going to be a lot of activity over the next few months around this. Or better yet, you tell us. Obviously, I'm just working on Azure, but we are trying to get a number of people across the industry working on this together. And if you have particular things that would impact you or have been successful for you, we'd love to hear it. And I always like to end in this slide. The people in this room don't have the ability to change the world. I'm sorry to be pessimistic. But you have the ability to give tools to the people who actually can. Don't think that you're going to understand better than an environmental scientist or a city landscaper or an architect or something like that. But you can give them the tools to make them better. And it's through things like you see up here that will help them do that. By giving them easy to use tools that are explainable, that are understandable, that they can use with a minimum of bias and basically unwinding a lot of historical badness, we can all work together to help make the world a better place. I know, very tech bro-y, but it's true. And with that, thank you very much. This is all me. You can see some examples of the stuff here. I didn't want to waste all our time just showing you, like I said, click on one, stuff happens over there. But you can see all these live examples. And with that,
as people are coming up, let me ask a question real quick. How many of you are doing ML in your shop today? Awesome, awesome. How about doing MLOps of some flavor? Okay. If you raise your hand at any time, we'd still love to have you up here. You don't have to ask questions, but there's might be some good opportunities for you to participate. Good opportunities for you to maybe ask a question that somebody else is thinking, or maybe provide feedback that will help the person next to you without even realizing how valuable it is. Everyone's opinions, thoughts are valuable here, so thank you. And David, you are absolutely welcome to escape. You're also welcome to join us.
Challenges.
Challenges. So does anybody have any challenges? Anything about MLOps that you've seen so far, or thoughts about MLOps that have been challenging?
So one I'm facing right now, and actually I've got Jira tickets to work on when I go back to work tomorrow, is sharing data models between different siloed environments where I've got very strict limitations about who can access it, but there's a need to share the model, and the model sizes can be large, as you mentioned in your talk there. Yeah, that spoke very deeply to what I'm trying to face and fix. So that's my challenge.
Are there any thoughts on that challenge?
you're not alone.
No.
It's super hard, and I think that one of the things I talked about yesterday is that we need to build tooling that takes data and models as a first-class citizen. Like right now, we're focused on building software in usually distributed systems type of contexts, and that makes it hard to deal with things that are like massive data sets or large compiled models or anything like that. So yeah, I just think that the tooling needs to be first class, make data and models a first class citizen.
One of the challenges we have is that in the rare instances where we deploy the model with a service with an end-to-end sort of GitOps setup, what that ends up doing is it puts the data scientists in the same repo as the services engineers, and then the repo is sort of split down the middle, which makes ownership and like responsibility very unclear. For external people, if you're on either of those teams, it's obvious, like, oh, here's the iPython notebooks and here's the serverless stack, and I know where to go. But for literally anyone else, it's not obvious, and so it's challenging to figure out how to merge those things in an effective manner.
Do you end up putting any of the ML models behind like a network service so that you basically have a consistent wrapper that you stick around the model and then everything else calls it over the network?
Yes, but then you put the network service in the GitHub repo with the ML model, and then the data scientists don't want to deal with the network service. And then, yeah, so it's...
I like mono repos, and so that's just a tool. That's a problem that I solve through tooling, usually. But yeah, I hear that pain. I see that pain often.
Unfortunately, I have a question for David, but you mentioned that the Azure MLOps stuff has tools for versioning and so forth, your ML systems. Are those open standards, or are those basically a Microsoft API?
So they're not open standards yet. Our SDK is open source, and you can use it from anywhere. So you could use it, you could store, or you could profile, or you could validate using an open Python SDK. We are working like that. Those are some of the standards that I would love to develop as an industry. Say like, here's the statistics for a data set, for example. What would a proto look like that you would use to describe the statistics of a data set? Doesn't have to be particularly sophisticated, but if you had that proto, now you could drive a step in a CI/CD pipeline saying, oh, I've done my statistics analysis. Can I move forward, yes or no? Like, the statistics are within the range that I expect them to be. So that's something that I'm working on right now. But the TLDR is from anywhere, from my laptop or any cloud, you can use any of those tools that you saw up there. Obviously, you need a subscription or something like that, but it's very, very cost limited. And then, but over time, I'd love to develop standards and work across the industry.
Yeah, I really like that idea because one of the challenges that I see very frequently in this place is that sometimes we think about data science as coming in because it's so research oriented to be sort of at the beginning of the process, and the data scientists sort of need to experiment to iterate, and then they build a model, and then we do all the fancy stuff to ship it, and it's hard. But what I'd actually like to see is us tightening up the loop more with the data ingestion and getting smarter about doing things like anomaly detection and integrating the building and the deployment of machine learning models way before that training process. So if we can integrate into our ingestion pipelines and stuff, that would be incredible. Because one of the challenges that I see is like data is super unreliable, and services fall over, the distributions shift because something is broken somewhere in this complex stack that you don't know, and you may not want to retrain a model. You may want to retrain a model. It's really hard to do that decisioning. So I just think that the loop is just way too open.
You're welcome to come down here and participate.
Yeah.
You're not kicked out once you do that.
Dave,
I've said enough words.
yeah, David didn't go through orientation, so.
Oh, no, I completely agree. Sorry. The number of times if you've been a data scientist or you've seen this, like where things are done completely ad hoc, like and I'll say personally, for example, the number of times I have converted null to 0 and then forgotten to update later, like my production environment to say like nulls are 0, is large. And that's terrible, and it happens. But that's because everything is disconnected right now. So the ability for us to bring this together and formalize it as standard contracts is incredibly important.
So if there are no more challenges, I think we're ready to move into the successes. Some great successes here, right? Let's hear them.
I'll say one thing. I'm going to sound like a broken record for everybody who was at Emily's talk, but very common themes here. I work with a lot of enterprises, and one of the things that they are struggling very hard with is understanding the operations piece of it. And so, like, you've got these great data models, and you pitch them over to the wall to SRE and DevOps teams in order to get them out, and like it takes forever. To your point, one of the successes that I have seen that I'm hoping to figure out how to replicate with other customers is making tooling for the data scientists to be able to choose versions of their models to be able to switch on and off in production and be able to say like, okay, now this is ready for shadow mode. Okay, now this version is ready for canary. Okay, now it's ready for full-scale deployment. And while it's in full-scale deployment, we're going to watch for anomalies to get back into the data lake so we can do a retraining. But right now, that tooling is entirely custom. It's like there's no out-of-the-box way to make this easy for companies. So I'd love to see that personally. More of that kind of stuff.
I think along those lines, one of the best tools that I've seen, it's not quite in that vein, but some of the stuff that MLflow is doing now, especially with their model repos and connecting it into the experimentation process, I think that's a nice step forward. It's a different part of the process, but it does put that sort of very visual and contextual workflow in front of data scientists who generally are not trained in delivery software engineering. And frankly, as you mentioned, it's like it's not realistic to train everyone to be a PhD in statistics. It's also not realistic to train every data scientist to become a DevOps, 10-year plus experienced DevOps person in 1 year. And that's what it takes right now to ship machine learning. Like, you need to have really good DevOps people there, and it's hard.
Yeah, we had there was an ML informal ML group of people that got together from some very large people at a conference I went to recently, Netflix and Lyft and so on and so forth. And it's really interesting the number of people who are still using Jupyter, like a Jupyter notebook, as the artifact for a lot of your ML, which is, it's good, but it's bad, right? Like, obviously, Jupyter notebooks are not particularly well designed for production, but there are some tools right now. So in Kubeflow, there's a tool called Kale. The folks behind Fast AI, the organization who's doing amazing work around NLP, Jeremy Howard released a tool called nb.dev. These are great tools that take your notebook and break them down into raw Python scripts. And split them up in ways that you can now do a lot of much more granular testing and things like that. So I'm a huge fan of both of those, whether or not you're using something like Kubeflow or just doing it on your own. The reality is that what you saw with all those that graph with the black dots and the data scientists and the MRE or the SRE is data science right now really is a series of interconnected tools, right? It might be Jupyter, it might be MLflow, it might be Kubeflow, it might be hosted services, SageMaker, Azure, doesn't matter what. And it's really all about piecing them together. And so that's why I do really strongly suggest, and this is something we're working on with the industry, pulling together folks across the industry to deliver better CD tools, CI/CD tools that integrate, that don't try and rewrite everything, but in fact let MLflow be a great experimentation tool for that data scientist, or let Kubeflow be a great rollout tool for inference or training, or let whatever, hosted service foo do your model profiling for you, because actually you really don't want to do model profiling on your own. It's really computationally intensive and annoying and so on and so forth. But have that CD tool be able to integrate with all of them.
A pattern that I found really successful here is The first thing of if you make the network setup or the deployment setup understandable enough for just data scientists to work on it. If it's not, you add a services engineer, someone who writes in like Python or Ruby or JS 99% of the day. And then the thing that I found successful is actually explicitly taking the infrastructure SRE developer productivity person out of that loop. So what I do in practice is I sit in the like sprint repos for my data scientists and services team pairs, and I have like a collector pattern where I'm just I look for any given PR. I just have like a little timer, like that took you 4 days because AWS permissions or something, right? And I have like long lists of that. But whenever I have to be synchronously in that loop, I lose the ability to really effectively optimize other people's workflows, right? So if you can design like nice 2-person max pairs with like a data scientist, someone writes Python all day for services, like a designer or a product person as is the support, right? And explicitly not the like tooling person. But make sure the tooling people are like aware and are empowered to sort of go out and know what everyone's pain points are.
Thank you. Great talk, David.
Oh, thank you.
It's difficult to talk about machine learning without getting into sensitive topics. And with all due respect, David, thank you for all the work you do. I wonder, with any vision and all of these other products with biases, you did address that, and I am a newbie, so I'm learning these things. This is hard. Biases are inherent. Models get stale quickly. You did mention that. I wonder, I'm just wondering aloud here, if we have a grasp on this Frankenstein that we might have unleashed, we just grease the rails and make these models, deploy them into production the world over, because we can. Hey, the cloud is ubiquitous. And we have not an effing clue that a model that is trained here, what is that going to do in Israel? How's that going to work? Who's going to answer these questions? Are these conversations happening? Am I out of the loop? Are these things being tested? Please educate me.
Yeah, so look, this is the hot topic in all of machine learning. You might hear the term responsible AI or reproducible AI. It's incredibly, incredibly important things. There are basically 2 things that everyone needs to be aware of. The first is that models are not in and of themselves biased. The data is biased, and then the objective function that they're being targeted to is biased because society is biased. And we need to be aware of that immediately and constantly be observing what's going on. And so the first step is just awareness that this is what exists in the world. The second thing is there are a large set of tools right now that help to identify when your model is issuing biased results, okay? It doesn't try and detect bias, but what it does is it'll take, you say, okay, these are protected classes, or these are differentiations across my entire population. Here's France, and here's the US, and here's Israel, or here's African Americans, and here's Hispanics, and here's Caucasians, whatever it might be. It's your job to look and say, okay, these are protected classes that I want to be aware of, and then what the tooling does is it'll run slices against your model, and it'll say, oh, do you know that you issued 22% less loans to African Americans, for example? And so it'll surface that to you. It doesn't tell you whether or not that's bias or not, but it does show a great difference in what's going on there. Yeah.
Who's that you whose responsibility that is? I hope that's not literally me, because I'm not a sociologist, I'm not a politician, and I don't know this. Somebody better own that up, and I'm not at all sure anybody's doing it.
So it is you, because the way corporate environments work today, so let's say you had a Starbucks, for example, and you were a barista at the Starbucks. It is illegal in the United States to say anyone to not serve someone because they are part of a protected class. So there's no ML there, right? Protected class is a legal term, by the way, right? It is race, gender, ethnicity, religion, sexual orientation, so on and so forth. You are not allowed by corporate law, by all sorts of legal legal requirements today. You are not allowed to split based purely on any of those factors. So if you're doing that today, as in your coffee shop, you're going to be arrested or sued or whatever it is. And you do that with ML, similarly, you're going to be sued or whatever. And that's incredibly important for us as data scientists to understand. Now, to be clear, if your application is doing that, set aside ML. If your application is doing that, just as bad.
So just wanted to throw in that one of the things that my company is doing, we've actually got an AI ethics board where we're actually bringing in internal and external people, pros and cons people, and they have a lot of regular discussions about the applications of AI and machine learning and all of those kind of things. So I think trumping our horn a little bit, but that is a great thing that I think we're doing, and it needs to be more of it.
So usually they bring me into these conferences to get a little political and a little radical, because that's a little bit who I am. And I'm going to throw a little bit of a monkey wrench in there. One, to the point of the legality. It is currently illegal, but it happens all of the time. Absolutely. And models will obscure that. Second, regarding the ethics and the corporate responsibility, I've stopped talking about technology ethics entirely because I am no longer of the opinion that we will ever, as technologists, create an ethical code or a set of practices that will interrupt the flow of capital. And so, to your point, like there are things that will happen with these models, and we are more likely to attempt to use our skills to math wash or to ethics wash the problem away, because we will naturally want to make more money and absolve ourselves of our sins. With all of that in mind, one of the promising patterns is that in a continuous delivery context or in a modern software development context, people generally have the ability to change production environments quickly, to shift versions out, to roll back, to roll forward, things like that. The genie is out of the bottle. So I think it's even more important for us to get to a point where we are able to deploy things quickly to production, to be able to turn off models, to be able to roll back to simpler ones. And I would say that if you're looking at any deployment of an automated solution, that one of your possible options at any given point should just be a pass-through where it doesn't do anything, or a fallback where it resorts to something that is less complicated, a less complicated model that is more explainable. So I think that there are ways that we can engineer protections, but we should also be very cognizant of the fact that either we need to solve this now, because the revolution is going to come for us.
I agree.
Oh, I had a different topic, so if you have more to say here, you should go first.
I'll just say two quick things. The first is I'm sure I'm crazy optimistic. I also agree the flow of capital is a nightmare. That said, I think that a lot of historical biases are wired into the system, and my optimism is that a lot of people are being rejected by capital today due to systemic biases. Over time, I think that those people will be revealed to be money opportunities for capital, and these people who were previously getting loans denied will hopefully get their loans approved because the math will say it. Now, again, that's very optimistic. The most important thing that I want to say is technology is not neutral. Everyone in this room needs to be aware of that. Go find your whistleblower hotline. If you are seeing your company misbehaving, call the whistleblowers. I'm not saying it's going to make you a lot of money, but it may make you a lot of money. Report it. Be honest. Show your management chain. Show them the liability that is in front of them if they don't do this, because if nothing else, capital protects capital. And if they see capital at risk, then that's bad times.
So we're officially out of time. There was one more in the queue, so let's do that.
Oh, that's okay. So this was about what do you want to see in 2 to 5 years? And I was wondering, whether people saw the tools moving to protect the data scientists from needing to understand the deployment, or the tools improving the understanding, and the expectation would be that data scientists would take responsibility for the deployment in the same way that developers are being expected to take responsibility for deployment for their DevOps.
So I think that right now what we're seeing is that the tools are moving to shield some of the data scientists from some of that work, and I think that's the wrong direction to go. I think that I think that if we look at how similar tools have been built in software engineering contexts, they have been made to simplify and streamline the processes, but a software engineer today does a little bit more, is a little bit more savvy about things like infrastructure than they were 5 or 10 years ago, for example. I'm not seeing the tools, some of the tools are, but some of the tools aren't, making data scientists more savvy to things like infrastructure. I think that they're trying to oversimplify some of it. Like, you don't need to know about this. I'm just going to do this Docker thing for you. You might vaguely need to know that, like, you have to have a Docker somewhere, but you don't need to know what it is. And so I think that eventually we'll see a similar thing where we'll have better tools for data scientists that make the process easier, but don't shield them from it.
So with that, I'm going to wrap it up. Obviously, we still have hallway discussions. We have a lot of great discussions here today. Thank you very much for everyone for participating.